Welcome everyone to this first ASTRAIOS Info Session, during which we will discover space opportunities, study, work and research across EU-27 and the UK, and we're very glad to have you all with us today. The info session will begin in a few minutes, and just a quick reminder that the session will be recorded. And to ensure a smooth experience for everyone, we kindly ask the participants to turn off their camera and also mute their microphone. I would like to also introduce you to our speakers today. We're very glad to have some of our distinguished partners contributing to this info session. We will start with an introductory presentation by Marie Kolimanen, who is the coordinator of ASTRAIOS from the European Science Foundation, and we will, together with her, we will learn about the goals and the scope of the project. Then we will move on to a presentation given by Grazia Maria Fiore from FDC, and we will, together with her, we will explore the space sector, discover the job markets and career paths in satellites, AI, engineering, policy and research. Following that, we will have a talk given by Yola Al-Asmar, who is a lecturer at the Department of Earth Observation and Science at the University of Twente, and with her we will discover the academic and research opportunities and find out how we can use the ASTRAIOS web catalog, which will help us to identify study and training options across the EU and the UK. Following her presentation, we are very honored to have with us Monika Brantic-Lipinska. I hope I spelled her name correctly. And we are very honored to have her today. And with her, we will learn and get inspired about having a successful professional career in this sector. If you have any questions for the speakers, please write them along the chat with your name, your country, and the name of the speaker that your question is addressed to. And all the questions will be addressed and answered during the Q&A session at the end of this 1 hour. With that, I would like to invite you to explore the project website and social media links. And here are the QR codes that you can scan to connect with us and explore more through the website, LinkedIn, X, and the YouTube channel. I thank you all for joining us today, and I wish you a lovely and insightful info session. Let's now take the floor and give the floor to Marie to start with the first presentation. Marie, the floor is yours.
Okay, thank you very much, Silva. Yes, my name is Marie Kolimanen. I'm a science officer and the head of the space cluster at the European Science Foundation, based in Strasbourg in France, and I'm also the coordinator for this project. And just to introduce the project itself, ASTRAIOS is a Horizon Europe project that is funded by the European Commission, and the acronym stands for Analysis of Skills, Training, Research and Innovation Opportunities in Space. Okay. The rationale for our project comes from this ever-growing need for space industry, both in Europe and globally, and with qualified people that are required to fulfill this growing potential. So ASTRAIOS aims to answer the question, do the skills provided by higher education institutions in the EU and the UK, do they match the needs of the space industry in Europe? And our objectives to help answer this question are, on one hand, to provide a full view of the current offer of space curricula in the EU-27 plus the UK, as well as characterize the future skills demand from the European space industry and space agencies in Europe. We want to identify potential gaps in skills needs, geographical gaps within Europe, as well as in student and workforce mobility, and to also consider the inclusiveness and diversity aspect. Our aim is to identify concrete actions to help harmonize the EU space curricula and skills required by the space sector. Okay, we have 10 partners across 6 European countries. We at ESF, we are the coordinators, and we work together with our academic partners, University of Twente in the Netherlands, University of Strathclyde in the UK, the International Space University in France, Technical University of Crete in Greece, and EASN Technology Innovation Services, where Silva comes from, who have their headquarters in Belgium, but are scattered across Europe, as far as I'm aware. And our industry partners are ASO from Germany, and they host one of the European Space Agency's business incubation centers for startups. We have SME for Space, who are based in Belgium, and they are this umbrella organization representing space industry SMEs, SMEs being small and medium-sized enterprises. FDC, Grazia will give the next presentation after me. FDC are a big consultancy company focusing on Earth observation, positioning, navigation and timing, telecommunications, among other things. And they are based in France. And last but certainly not least, Space Skills Alliance are a company in the UK who are experts, as the name suggests, in space skills, especially the skills gaps in the space sector, as well as training and recruitment opportunities within the sector. For our project outcomes, so ASTRAIOS kicked off 2.5 years ago now, roughly, in the beginning of 2023, and we spent the first year working on the status quo analysis, which was to map the current offer of space curricula and courses in the EU and the UK. And this resulted in one of our main results, which is a database for space education in Europe. Jolla will talk a bit more about this a bit later on. And we also put together a new space knowledge taxonomy for the space sector. We worked to identify the skills need and the demand for future workforce from space industry side to complement this educational mapping. And now that we are in our final year of the project, absolutely everything will come together by the end of this year, fingers crossed. And the results from our gap analysis will be used to produce new online training courses for Copernicus and Galileo, which are the 2 EU flagship missions, Copernicus for Earth observation and Galileo for positioning, navigation and timing. New outreach material has been created to promote space studies and space career opportunities, which is the reason why we're all here today. And by the end of this year, our goal is to have a one-stop database that will include all the outputs from our project, as well as concrete recommendations to policymakers for adapting EU space education to future industry and to help better align the skills with workforce demands in the space sector in general. And with that, I will finish. Thank you very much, and looking forward to the following presentations on the actual output so far. Thank you very much, Silva and everyone.
Thank you, Marie. And I think now that we learned on what ASTRAIOS is trying to accomplish and achieve, I think we can move on to the next presentation, which will be kindly presented and delivered by Grazia. Thank you, Grazia.
Between the objectives of ASTRAIOS, there is the mapping of the European space sector to try to understand where the jobs will be created in the future. So in this presentation, I've put together a bit a description of the variety of jobs that exist in the space sector throughout the whole value chain of the space economy. I've been working now for over 13 years in the sector, and I had the opportunity to see that there are a variety of users working in space, and I've been exploring a lot the applications domain, and I've also been working with the so-called final users of these services, which are in the end the public institutions and through regional and local administrations and private companies. So ASTRAIOS has been identifying 3 major developments in Europe that will create new need for skills in the future. The LISA mission for gravitational wave detection in space, and the continued and extended human exploration of Moon and Mars for what concerns the upstream part of the space economy and the research on outer space, and an increasing need for Earth observation data and analytical tools, especially for climate analysis and for societal and commercial actors, the final users we were talking about afterwards. Other technological developments and trends that will require and might require adapted skills in the future and adapted workforce are the developments related to IRIS², which is the secure satellite communication program of the EU that is completing in the next years. An increased need to protect GNSS signals against spoofing and jamming. The increasing need to integrate artificial intelligence and machine learning to analyze big data, including data from satellite imagery. The increasing use of both GNSS and Earth observation data for virtual reality reconstructions and the so-called digital twins, and an increasing interest towards cybersecurity. So these are the results that have been put together by our colleague Heidi Tillmans from Alliance for Skills, from the Skills Alliance, from the UK. She analyzed 270,000 LinkedIn profiles of people who could be identified through keywords as working in the space sector. And moreover, the project has been analyzing over 6,000 CVs of people working in the sector, trying to identify trends and a bit about the professional path of these people, including migration from countries and from sectors between and outside the space sector. This analysis showed that the most common fields of study of people working in the space sector are computer science, general engineering, and electronics engineering. Nevertheless, the space sector is much more than these fields, and in the next slides, I'm going to give you a very short overview of the space economy value chain and the kind of jobs that you can expect to get in these subsectors of the space wider sector. So at the beginning, we have the manufacturing of the space assets and the ground segments. So the infrastructure that will allow us to collect the space data. On a second phase, these data are transmitted to satellites and equipment such as the receivers, transmitters, antennas. All this data needs to be analyzed and turned into information that can be processed in the third part of the value chain, which concerns space applications. In this part of the value chain, we have a big number and very rich European ecosystem of SMEs and companies, also large companies that produce both the hardware and software that is needed to receive Earth observation imagery, satellite communications, GNSS signals, and that turn this data into services that then can be used in various fields. These fields include agriculture, include transport, environmental protection, urban planning, architecture, cultural heritage monitoring, and many, many others, including sporting, outdoor activities, and entertaining. So there is actually a myriad of opportunities for people who are able to take satellite data and to turn it into services and information that can be used by public society. At the bottom part of the space economy value chain, we also have the regulatory and essential service delivery. So there is all a legal part that goes within the creation of space infrastructure, of satellite data. There are no careers today for space lawyers. There are international treaties in this area that need to be applied then at the national level. And so there are jobs for legal experts as well. There is the whole part of the infrastructure and capabilities, which includes education and training. So all people who work at the universities, but also on educational programs at other levels, at the high school and primary levels. There is the research, development, and engineering that is carried out by universities, but also by public companies and private companies, by public institutions and private companies. And then there are the specialized support services, once again, the legal services. In each of these parts of the value chain, there are public operators, private companies, and international organizations and NGOs which produce or need or use or can use data and information coming from space infrastructure. Going a bit into the areas of employment in space. This can be divided in the big areas are aerospace and engineering, satellite system, space science, and then related fields like robotics and software development, plus technical roles, for example, avionics technicians or aerospace technicians. Looking at the engineering and technology domain, you have different roles that you could imagine having as working in the space sector, such as aerospace engineer, which will be the one designing and developing the aircraft and the spacecraft, the avionics engineer, which will work with the electronic systems specifically for aircraft and spacecraft, including also communication, navigation, and radar. Spacecraft engineer, satellite system engineer, robotics engineer, software engineer, or hardware engineer. So there are actually, according to your field of study and your field of interest, there are a number of topics in which you can focus if your primary field of study is engineering and you want to go more in depth into the space and the aerospace sector. Of course, there is science and research. Some of the roles that you can find in this biggest area are the role of atmospheric scientists that studies the Earth's atmosphere and its relationship with space. You can be an astrophysicist, you can be a space scientist, you can be a research scientist and conduct hands-on research on various aspects of space. Moreover, there are roles to which normally we don't think, but that are quite needed throughout the space economy value chain in business and management. So you need people to manage products, to bring them to market. You need financial analysts, policy analysts in the sector, and of course, business development managers and space industry managers. And all these need to have, in addition to knowledge of their technical sectors, also managerial skills and possibly some managerial curricular expertise. Finally, you have project managers, you have communications officers. There is a big need to communicate about space to civil society, and experts in communication can gain expertise of space and turn into space communicators. And in the same way, space experts can get communication skills and find a career in communications. So, and finally, you can also decide that your passion is to educate on space and become an expert in developing educational materials on this topic, since projects like ASTRAIOS exist because there is need for this kind of training materials. So this was to give you a bit an overview of what a career in space may mean, and of how broad the range of opportunities are. I thank both Heidi Thiemann and Marie Colmenin for contributing with contents to this presentation, and I'll stop sharing my screen.
Great. Thank you very much, Gracia. It was interesting to learn more on the diverse types of roles that different kinds of professionals can contribute to the space sector and work in it, and widen the spectrum of the space sector landscape. Now we move on to a very interesting talk by Yola, who will give us a presentation on to use the very useful ASTRAIOS web catalog, and we look forward to learning more on how to use it and its benefits, and how we can further maximize its functionalities. Thank you, Yola. The floor is yours.
Okay, thank you. So, hello everyone. My name is Yola Al-Asmar. I'm part of the team. I work as a lecturer at the University of Twente as a faculty of ITC, and was part of the team who developed this web catalog. Now, in my presentation, I will give you a bit of introduction about the web catalog, the methodology. I will also give you some example how we use this web catalog to answer a question or to extract information. And I will, if we have time, I will also make a demo. So the ASTRAIOS web catalog was developed because one of the main objectives of the project, of the ASTRAIOS project, is to provide a comprehensive overview of the current space-related curricula in the project area in the EU plus UK. So what we did, we tried to collect a representative sample of some of degree programs at different levels, as the bachelor, master, PhD levels. As well, we collected also information or information about the courses, which we call it continuing education courses, which are courses, certified courses aimed to improve the knowledge in a specific area of space sector. To be able to disseminate and visualize the result, we developed this ASTRAIOS web catalog using the linked data technology, where it's make the items that help, or it have the functionality that connect the items with relationship. And you will see that this web catalog is easy to navigate, as well as also easy to integrate additional program and courses. The web catalogs, you will see that is composed of 4 tabs. The first tab is related to degree programs, where you can explore or find the information that's related to the courses collected, or to the degree program collected at the bachelor and the master level. The second tab is degree program courses. You will find all of the information about the courses that associated with the degree program at the master and the bachelor level. We also have the third tab, which is related to the PhD programs, and the last tab related to the continuation education or continuing education courses. For now, I would like to also explain a bit about the methodology, how we did that. The first step, we have the several steps. The first step was related to design and implement as ASTRAIOS database. It was designed and implemented in a rational database, and we identify what the data to be collected. On a parallel steps, first we identify the relevant sector educational program at the different level, plus continuing education. We follow criteria related to geographic coverage, thematic diversity, and diversity also across the different space sectors. On a parallel step, we also want to thematically structure the relevant to thematic structure not the program or the collected degree program and courses. So we define the taxonomy that is composed of 2-level hierarchy. The upper level hierarchy, which we call it the knowledge domains, have the broadest knowledge, or which we call it knowledge domain, such as, for example, remote sensing. The second level, which have subclasses, have more specialized areas of knowledge. For example, that's relevant to the upper hierarchy, remote sensing, for example, instrument and image analysis. Now, after this step, we collect and structure the information. The collection is done by desk-based approach, as well as a survey, and some also more advanced method like text, web crawling and text mapping. And the final step, we have the implementation of the ASTRAIOS online catalog. Of course, we were also trying to do a quality check of all of these steps. Now here I want to represent the ASTRAIOS database that it was designed and structured, and you will see that all of the data here, you could also collect it. You also could extract it, that was collected. You can also extract it from the web catalog. The database was designed and built on a relational database, and it's composed of 7 main tables. So we have the first table related to the institution, the second table that's related to the faculty, the third table that's related to the degree programs, where we collected all of the information, or we collected all the degree programs on the master and the bachelor level. For each degree programs, you can find information related to the name of the degree program, the level, what is the duration in years, 1 or 2 years, do you have a scholarship, yes or no, what is the tuition fee of this degree program, the graduation conditions, like do you have thesis or you need exam or both, is the internship is mandatory or optional, is it part of the joint program or not. We also try to map the degree programs following the knowledge domain, and we identify 28 in total. We also map these degree programs according to the space sector value chain, where we have upstream, midstream, and downstream. So the upstream sectors covers space platforms, covers area related to space platforms, payload, and group equipment. The midstream covers ground segments operation and data management. And this is the upstream. We have the midstream, and the last one is the downstream. We covered area like user segments, data provision, and services and application. We also have, that is related to this degree programs, we have the associated courses that related to this degree programs, where you could find information related to the name of the course, the credits, delivery method, is presential or online, is it mandatory or elective, description, and we also mapped it according to second level of our taxonomy, which is the knowledge area. And in total, we have 105 knowledge area. We also have the information related to the PhD programs, as well as the continuing education courses. So the result that we have, we collected in total 132 degree programs, 25 at the bachelor level, and 107 at the master level. Figure 1 here showed the spatial distribution of the analyzed degree programs, where we see that we have a higher percentage or higher numbers in UK or France and the Netherlands. Figure 2 showed the distribution of the degree programs across the upstream, downstream, and midstream sector. So in bachelor and master degree, you have the highest percentage in the upstream, followed by the downstream, and finally the midstream. For the PhD program, we identified and collected 19 PhD programs, 10 of them related to the Marie Curie doctoral network, and we collected 248 PhD positions, which are ongoing PhD projects and PhD positions offered in 2023. And for the continuing educations, we collected 60 certified courses, including summer school, and we found that the summer school represented 33.3% of the total selected continuing education courses, where 90 are offered face-to-face. So how can I use this web catalog? You can use this web catalog to answer questions that, for example, on the project level. So what are the key knowledge domains associated with the Identify MSc, the master degree program? So if I go to this web catalog and I select the degree programs, I will have this interface. By filtering according to the program, according to the level, according to European qualification framework and the knowledge domain, I could also have the result to show me what are the key domains, knowledge domains in the master program. I could present them like this, like for example, remote sensing represented 31, geographic or GIS 28. I could also present them in another visualization like this tag cloud. I could also ask different questions, like for example, which universities in the project area are offering master degree or master program in AI area domain? Or I could also ask about tuition fees. What is the tuition fee for a specific master or bachelor program in EU, or I want to know exactly in UK? Now, if I want to go more in detail, I could also find all of the courses that are associated with a specific master program. Or I could also, for each one of these courses, I could also understand the duration, the EST credits, and so on. Also, another example is like what ongoing PhD projects and PhD positions that are available at a specific institute like University of Twente. And of course, there's much more. This is just some examples. So if I go to the ASTRAIOS website, I will give you some example. Let's go with the degree programs. And in the degree programs, I will ask questions according, for example, to the knowledge area. So I'll start with, for example, I want to find all of the master degree programs that is related to the knowledge domain that is in remote sensing, and that they are in, for example, the Netherlands. Here I find all of the listed of the master program or that follow the 3 selection criteria. Now, if I select the Master of Geoinformation and Earth Observation Science, I get this information like number of credits. It's a master degree, delivery method is presential. I give a description, the duration is 2 years, graduation condition, it thesis, and so on. And we have like number 7, specialization of track, program provider, the institute is ITC. I could also from here go to all the courses that are associated with this master degree. And for each of these courses, I could also select like, let's say laser scanning. I could also, so number of credits, is it the delivery method? Is it mandatory? No, that means it's an elective. And what is the knowledge area that's associated with this degree? Now, if I go back, and for example, I want to find information about the courses, I could go here. And in this case, I want to map the courses according to the knowledge area, to the institution, for example, and let's say the language. And from here, I could select, give me all of these courses that are taught, that's related to the knowledge area, remote sensing, that are taught in Greek, in the Cyper University of Technology. And from here, and all of these courses, when I select them, I could also find all of the previous mentioned information. Same for the PhD programs. So I could also have information related to the institution, to the language, and for example, the program name. Here, language, we only have information that we documented related to, collected related to English. So, okay. And so on. So if I select the University of Twente, for example, I will have all of these PhD opportunity. And when I select one of these PhD opportunity, I also have more information. The same, if I go back, the same apply for the continuing education courses. For example, we're following knowledge area, remote sensing, and spacecraft, and then I can select or understand more information about this program. So thank you. I hope it's also useful for you, and you could also use it. I just also need to mention that all of the data that's selected in 2023. Thank you. I'll stop sharing. I hope I was on time as well.
Yes, you were perfectly on time. Thank you, Yola. It was very interesting, and I think the demo that you did on how a visitor can search and cruise around the catalog will be very useful for young professionals and for anyone interested to develop a career in the space sector and study further and
explore as well, because this is give you an information. It's that also they have to understand that it's just a sample. It's not everything, could not document everything.
Yes,
but this could give you an general, like not even general, like an overview for what's happening in the space sector in the project area, and how can they drive information, how can they compare. This helps them for decision making, either like when they define their space sector, space career.
Specialization, yeah,
Yeah.
as well. Yes, and I also like very much the continuing education courses which are included in there, which will be, I assume, very helpful for anyone wanting to further upskill their skills and knowledge, which will be very interesting for anyone in mid-career level, let's say, for example.
And we have also documented some of the collected, or there's in the catalog, we have also some summer schools, which is really very relevant for students, or sometimes also for mid-career, that they can go through summer. And as I mentioned, most of them is face-to-face. That's also very helpful.
Yeah. Okay, great. Thank you very much, Yola. And now I'm very pleased to have with us Monica, who will share her personal experience and journey as a woman professional in the space sector. And we're very excited to learn more about her experience and her journey. Monica, the floor is yours. Thank you.
Hello, everyone. I'll share my screen. Okay, can you see it?
Yes, we can see it. Thank you.
Okay, great. Yeah, so thank you so much for having me. So I'm a space architect, and I want to tell you about my journey, and I have a couple of slides about what space architecture is, also to show you how different subjects it might involve, and within kind of one field is already very broad, so that can also translate to all of the other fields when you think what you can do in space industry, that it's really very broad field in general. So basically what I'm working with right now, it's biotechnologies for human habitation in space and extreme environments. And I put this slide just to like decompose it, what it contains. So like biotechnologies and space and human habitation and extreme environments, but it wasn't all of that at the same time. I started as an architect. I was studying architecture, bachelor in architecture in my hometown in Wrocław at Wrocław University of Science and Technology. I spent a year in Politecnico di Milano, but it was all like regular architecture and urban design. And then I took a gap year or year and a half to think of what I want to do. And when I came up with this idea of working with space and extreme environments, I looked for my master's studies that would already accommodate that. So I went to Lund University because they had like a program with Martian Studio, which was cancelled when I joined, but we still had like Sahara visit, and we were designing like this experimental architecture and extreme environments. So from Lund University, where I graduated as like with master in architecture, I wanted to continue towards the space. So I went to Space University to get that space, more general space background. And from Space University, I could do internships at NASA Ames Research Center, which was again something else, like a new step, because that was astrobiology lab. It was biotechnologies and astrobiology for growing habitats on Mars and on the moon. So I already had this architecture background. I had a little bit of space background. Then I combined it with biology background. Not really background, but I started working with biology. And then I was looking for something where I can get more of this biological expertise, because that's the direction that I wanted to go with. And I did my PhD at Hub for Biotechnology in Built Environment. So that was something that was combining architecture and biotechnology. And throughout this whole time, I was also working in the field of space architecture with Liquifer, which is a space architecture company based in Vienna and Bremen. So that gave me a little bit of more like a real space projects, but more grounded kind of space projects, like what's happening in industry and like actual projects, not just research and student ideas. I had a slide that also shows like this division between two, I don't know, eras for me. The first one was the architecture, and you can see a couple of flags on the bottom. This was different internships. So this is something that I was doing. I was driven by the location. So I was not really focused on like what I want to do. I just wanted to live in Tokyo, Copenhagen, San Francisco, and just explore. So I was choosing architecture companies in these places to be able to work from there and experience how it is to live there. And then where I realized what I want to do, it kind of shifted to like the location was driven by what is there. So I went to Lund University in Sweden. I went to Vienna to work with Liquefer, to Strasbourg for ISU, to NASA, and now I'm in Newcastle after I finished my PhD. So yeah. And then I have a couple of slides just to show you the general overview about space architecture. So in general, very general, it's basically about humans and about environment. So it's kind of like an architecture here on Earth. We're designing an environment for humans. It's just we have much more obstacles. And it involves human performance, human psychology and physiology, and just designing these spaces for astronauts, like interiors of space stations, interior habitat interiors and furnishing. So we're designing, for example, these crew quarters or chair from the elements, from reusable elements from different space station elements, like how to reuse materials. It involves life support systems, so projects like greenhouses, aspects connected to biophilia and human psychological well-being. It's also about structures and structures manufactured on Earth and assembled in situ. So how we can something make here and send it to space to be assembled, but also in situ resource visualization. So how we can use the resources that we find on the moon or Mars and make infrastructure or structural elements out of it to build habitats. So there's a lot of research into like material processing, how we can like sinter the regolith or laser melt the regolith to make like different bricks. It's a really interesting area of research that is more material science. What I'm personally researching as on my academic path, it's a utilization of biomaterials and biotechnology. So here's an example of habitat utilizing cellulose, bacterial cellulose, for reinforcement, but also for translucency, to like introduce the sunlight into the habitat. So again, we're going back to psychological aspects and well-being of astronauts. And here is my PhD project that was using mycelium, which is the vegetative part of fungi, to consolidate the regolith. So again, in situ resource utilization, to make like structural components and bricks that can later on bioweld together, like create this cohesive structure to allow for the construction on Mars. Here's some examples of more like artistic approaches and manifestos. So this is more space art than architecture, but also architecture kind of over, like it's a part of it, of like this more bold visionary ideas. It's not really something that we will be doing now, but like, you know, the covering craters and making close ecosystems, or building an arch on the moon as a manifesto of like building our new civilization, things like that. It's also part of space architecture. I also have a slide here with sustainability goals. So this is not specifically architecture job, but I was involved in that together with my colleagues at International Space University. We developed lunar sustainability goals, which I think it's a really, it's a thing that kind of connects different subjects, no matter what your discipline is. In the end, we're going to the moon or to the Mars, and we have to think about it, like how to do it sustainably. So this is an example of the project where I was involved into like this overarching thinking of how our actions impact sustainability and impact lunar environment, and like what are the aspects that we have to think about. So this is also something that might give you an idea of the direction you want to go with your career. And And I have a slide about public outreach, because alongside the actual work and working on projects, I'm also involved, and I think it's very important to be involved in things like conferences and symposia, organization of workshops, and sharing your knowledge and sharing your expertise, but also something that excites you. So, for example, I was hosting a podcast about water beyond Earth, so not really architecture, but this is part of it. This is like how we extract water and how we use resources, so the sustainable thinking. So this is, I think, very important aspect, no matter what your field is, to just be involved in that. And together with my colleagues, we started a platform called Biofutures for Transplanetary Habitats that gathers members who can share ideas, share projects, and work together on different subjects across these disciplines. So if any of you is interested in anything connected to biotechnologies, but also living in space and architecture, you can consider joining us, and maybe we can find some projects to work together on. And yeah, that's it from me.
It's very inspiring topic, and personally I really find it very interesting how you have connected the different dots, like health, safety, water, etc., into the field of space architecture and infrastructure. And it's very interesting to see how these things come together. Even if you are not a space scientist, you can still have a role based on your initial expertise. So we have a question for Yolla here. Is there a plan for long-term sustainability of the web catalog?
Okay, yeah, thank you for the question. Now we also try to, for the web catalog, we try to, as I mentioned, that make it easy to integrate additional information or courses there. And then there's a kind of a link that you could also send the information. We can add it to the web catalog. I'm not sure if there's a project that will continue, but we hope that also we build the collected information that we have, that's to be used to as a base for other projects as well for sustainability. The catalog itself, it's easy to integrate as well as to add more information to it, because if you have it, then we can, if the information is there, then we could just add it to the database and directly will be reflected on the website. I hope I answered your question.
Good to know that it can, I mean, any additional degree programs can be easily added onto the catalog, and it's easily implementable. I have another question from Ireland, Italy. Thank you for an engaging talk. To all speakers, what are the paths you would suggest to a senior communications and marketing pro with some data analytics and space knowledge to enter the space sector? It seems to me there is a gap between engineers and the general public. Thanks. Who would like to first answer from the speakers to this question?
Well, I guess it will depend from if you want to become a communicator or if you want to be merely a data analyst. I think that DigiDefis offers internships, for example, in which they look for people with some knowledge of the space sector to work on their communications websites. So this could be interesting. The Copernicus, the EU Space Support Office, for example, that is a platform to which FDC collaborates, has as a primary goal to spread information about the EU Space Program and its applications. And they publish every day a very nice satellite imagery that has been analyzed and modified visually to communicate on the beauty and the usefulness of space. There is quite a need for data analytics today. There are companies specializing in data analytics, and in particular from space, to collect data, even socioeconomic data on countries where information is not available. So I think that you also have now the portal, the Cassini the Space Career Launchpad, where you can find entry-level jobs that are proposed by companies in the space ecosystem, and you can propose your own candidature there as well. I know that many companies look for interns, propose internships, so you can have a look there, and you can definitely also identify the companies that are of interest for you and spontaneously apply.
I would
Yes.
also, sorry, if I may continue just for a bit.
Sure,
I would also
yeah.
just recommend applying to companies directly. There's a lot of companies that operate in the space sector that do employ marketing people, that have a separate marketing department completely, or who do communication. And just the fact that you have an interest in space sector normally is enough if you're applying into roles like in marketing or communication. I know for ESF as well, we don't require our communications officers to be space experts in any way, but it's something that you can grow into as well. Because normally if you get into a company in a position, a certain position, there's always room to move and to grow. And that way you can find yourself in the space sector with the background you already have, and go from there.
Viola or Monica, would you like to also add on any specific advice from your experience to this question?
Yeah, I think applying to companies, it's a good advice. Even I would add, if there is no specific opening, just start contacting people and sharing what you think you can give, or what you want to give, and seeing if there's any opportunities. Yeah, this is how I started with space architecture. I was not looking for a job opening because these didn't exist. I was just emailing companies, and it worked. So
you can always stay connected with the project through the website, our social media platforms on LinkedIn, X, and the YouTube channel, on which we have a rich content. We do keep them all updated with recent and upcoming events, opportunities, webinars, and very interesting testimonials specifically on the YouTube channel recently. I would like to also this info session will be published on the YouTube channel of the project. So whoever was not able to join now, they can join. They can watch the session on YouTube at a later stage and further share it. So before we wrap up, I just want to also mention that we do have part 2 of ASTRAIOS Info Sessions, and stay tuned for the next one on June 6th. Mark your calendars, and we will be communicating and sharing further information about it very soon. And I would like to thank all the speakers who joined us today and the audience, and we look forward to seeing you again during the next talk.